So the unit circle definition of sine, cosine, and tangent is the following. So measure up your angle as a rotational angle. Now, no matter what the angle is, there is always an intersection with the unit circle. Let that intersection point be P with two coordinates x and y. We define cosine of this angle to be the x coordinate of this point, sine of this angle to be the y coordinate of this point, and the tangent is y over x. That's the definition. So I think the first thing we should do is let's just worry about conflicts. So let's just think that this is 30 degrees. If this angle is 30 degrees and this is 90, we're dealing with the 30, 60, 90 triangle. Guess what? The hypotenuse is 1 because this is the unit circle we're in. So how long is this short side? That's the only thing you have to memorize. This short side is
1/2.
1/2. And this side, this is the longer one, that is square root of 3 over 2. Actually, this looks more like 35 degrees. Okay, so given that, let's use right triangle trigonometry. Well, we know that already, right? The sine of 30 should be half. Half over 1 is half. Cosine of 30 should be root 3 over 2 over 1, root 3 over 2. But now let's figure out what are the two coordinates of this point. What is the x coordinate of this point? You know, there was a problem on your homework when triangles were stuck in the coordinate system and you had to read the coordinates. You did phenomenal on this. This is where we were going. There is a triangle stuck into this coordinate system. It starts here, it goes to the right, how long? Square root of 3 over 2. And then it goes up 1/2. So the two coordinates of this point happen to be the x coordinate is we start at 0, we go to the positive direction, and we go this long. So this is the coordinate. And then this is the coordinate. Right? And so, x and y, first x, then y. Works if you alphabetize. Same with cosine and sine. So cosine is the first coordinate. C is before s in the alphabet. So the x coordinate of this point, square root of 3 over 2. So according to the unit circle definition, cosine of 30 is root 3 over 2, and sine of 30 is 1/2. Is there a conflict? Of course not. We wouldn't have this definition anyway. So this part of the coordinate system is called quadrant 1. Quadrant 1 is where the two trigonometries overlap. Quadrant 1 is where those angles live who can be fit in a right triangle, right? Those are the angles between 0 and 90. This point here represents 90 degrees. This is 180, 270, or minus 90, depending on what we're doing. This is 0 or 360. Oh, something cute. Did you know that 180 and minus 180 in this case, same thing. Tomato, tomato. Okay. Let's say that this is that freaky little triangle with hypotenuse 1, shorter side 1/2, longer side root 3 over 2. And what I want you to do is tell me the two coordinates of this point. What's the x coordinate? What's the y coordinate?
Negative square root of 3 over 2. And then negative, nope, regular 1/2.
Exactly. Long to the left, short up, right? So I don't believe in negative distances. The distances are positive, but we shove this triangle into the unit circle, and now the orientation of the triangle will decide, you know, this point, this is to the left of the y-axis. We went to the left, but also we went up. So the two coordinates of this point are negative square root of 3 over 2 and positive 1/2. Nothing to memorize, right? You can tell if you go to the left, then the x coordinate is negative. I hear people memorizing little poems to remember that. And, you know, the unit circle will remember for you. if this is the 30-60 triangle here, then what angle belongs with this point? This point represents what angle? I'll give you a hint. You have to find this angle.
150?
Exactly. Actually, you can just say, you know what? Why not just go back from 180 another 30? So this angle indeed is 150 degrees, but and we just figured out that cosine of 150 degrees is the first coordinate of this point, negative √3/2, and sine of 150 degrees is the second coordinate, the y coordinate, which is 1/2. But this is related to the 30-60-90 triangle, which we shoved into the unit circle. But then because of the orientation, there are now signed numbers. And guess what? There are 8 different ways you can shove this triangle into the unit circle. Here is our good old friend 30 degrees, right? Actually, this is what I do. You know, I don't have it memorized whether 30 has the sine is half or the cosine. I just close my eyes and I look at this. Even a sloppy little triangle will tell you. Here is 60, here is 30. You see, the vertical, in case of 30, the vertical is the short one. So that means sine of 30 is 1/2 and cosine of 30 is √3/2. I actually have this definition. I don't think of right triangles anymore. Well, this one in this circle. Here is our other good old friend, 60 degrees, right? Now you see the cosine, the x coordinate is the short one, therefore 1/2. So this here is telling you cosine of 60 is 1/2, sine of 60 is √3/2. Nothing to memorize. And then what? So this is 30, this was 60 degrees, this was 30 degrees. What is this angle?
120.
Yes.
90 degree
30.
plus 30 degree.
Exactly. Exactly. And it's going to be helpful for you to be able to draw these things pretty precisely. I had just one semester when there was this habit of everyone was carrying a quota to draw those unit circles. But to this day, trigonometry on the margin is always covered with unit circles. That's what we're studying pretty much. Okay, this is just way too sloppy. I'll try another one. So how do we draw something like 30-60-90 or related? Just focus on the arc and trisect it, cut it into 3, and then this is 30, this is 60. And this is 120, and this is 150. How much is this? How much is this angle? Okay, maybe this will help. Shaky hand. We are thinking about this angle here.
210.
Right, it's 180 plus an extra 30, 210. And then the next one, which again, just trisect the, let me see if I got it right. No, not even close. Yeah. What angle is this?
240.
240. All right. Now, the cosine of 240 is the first coordinate of this point. That's the x coordinate. What's that? Just use the orientation and the shorter, longer side to decide what is the first coordinate of this point. What is the x coordinate of this point?
-1/2.
There it is, -1/2 cosine of 240. What about the y coordinate, which would be sine of 240?
-√3/2.
Exactly. So yeah, I see people memorizing that long sheet with these 8 angles. It's just, there's no need. That said, you know, if you want to memorize, go ahead, go right ahead, but you don't have to. I don't think so. Okay. Give me 2 different numbers that could represent this angle. Say one positive, one negative.
330 degrees.
330 degrees. And also, you can just subtract 360 from this, but it would be just going this way until you reach this point. And remember, this here is, so as long as numbers are famous, and a whole lot of the problems are designed for famous angles. This is 30 degrees here. This angle here is 30 degrees, right? So what negative angle can we assign to this? Negative 30. It's going to the negative direction, right? This is the positive direction here. Counterclockwise. So it's negative 30. And half the time it will be beneficial for us to think of this angle as 330. The other half the times as negative 30. That's the 30, 60, 90 group. Now, if I got something crazy like 31 over 6 pi, and I was asked of the sine, cosine, and tangent of that, I would first go to degrees. I would say 31 over 6 times 180. 180 divided by 6 is 3. 30, right? It's 31 times 30 degrees, which is 930 degrees. I did not need a calculator for that, did I? 930 degrees, which is coterminal to 930. Let's subtract 720. 930 minus 720, 210. So you're going to get homework assignment where you have to find the sine, cosine, and tangent of this. Now, you don't have to, but the first thing I do is get rid of the radians. And then if the number is negative or too big, you can add and subtract 360s until you arrive to a place where you're more comfortable. We actually worked out 210 already, right? 210 is here. What's the cosine? What's the sine of 210 degrees? Cosine of 210. So I'm just going to say cosine of 31 over 6 pi equals to cosine of 210, which is
negative 0.86.
And what about the sine? What's sine of 210?
Negative 1/2.
Mm-hmm. Excellent. So correct. Now there are two other groups, but this is the one that gives people the most difficulty, but not anymore. You guys are okay with it now, right? There are two other groups of famous angles. I want to start with the most fun of them. They are brand new. This point, no right triangle, but can you figure out the two coordinates of this point? This is 1 here. We're in the unit circle, right? 1, 0. Thank you. And that means that 0 degrees, which would correspond to this ray, or 360 degrees, we can define sine and cosine to it. Cosine of 0 should be 1, because cosine is the first coordinate. Cosine of 0 should be 1. And sine of 0 should be 0. And that also is in harmony with, if you look at right triangle trigonometry, and you look at freakier and freakier examples where this angle is closer and closer to 0, guess what? The sine is going to get closer and closer and closer to 0. So it's kind of an organic, I don't know, closure for what's happening with angles that can sit in the, you're close to 0 degrees, the sine is going to be close to 0. You're close to 0 degrees, the cosine is going to be close to 1. Right? For the cosine, you're dividing this by that. All right. So cosine of 0 is 1, sine of 0 is 0. All right. Now you can redeem yourself with telling me the two coordinates of this point. And what angle does it represent?
0, 1.
And what angle would this represent?
Would it be 90 degrees?
Yeah. So cosine 90 should be the first coordinate 0, sine, oh, I'm sorry, I said 90. Cosine of 90 is the first coordinate 0, sine of 90 is the second coordinate, that should be 1. 1. I'm sorry. Sine of 90. There it is, it's 1. Okay, you know, it's a time waster to do, but there are four points altogether that were, there is no right triangle. But the Pythagorean theorem works on 0, 1, 0 squared plus 1 squared is 1 squared. But basically, these 4 points represent angles like 0, 90, 180, 270, 0, negative 90, negative 180, negative 270. So if it's divisible by 90, see, here is how you add 90, 90, add another 90, poof, add the 90, add the 90, add the 90. In general, if you have any angle and you want to add 90, just draw a perpendicular line. That's how you do it. It's going to be a lot of visual trickery. All right, so that's the second group. I think it's pretty straightforward, and your calculator is going to be next to you. So there is one more group, and that's the 45 degree and related. And so if we start with the 1, 1 root 2 triangle for 45 degrees, and we want to shove this into this unit circle, that means we have to scale it down so the hypotenuse is 1. Then the other numbers are going to be 1 over root 2. And so if you want to think about 45, think diagonal or the midpoint, this would be 45. This in the middle, what angle can we assign to this point?
That'd be 135.
So one way I want you to think about it is it's 90 plus another 45. You see, the right triangle trigonometry is not going anywhere. Right triangle trigonometry gave us the side lengths of this triangle. And every time you want to figure out lengths, we're going to go back to right triangle, but because of the orientation, we're going to have sines. So you can, and you should think of this angle as 90 plus 45, which is indeed 135. And what are the two coordinates of this point? What's the x coordinate of this point? So the sides are 1 over root 2 and 1 over root 2. You don't have to worry about longer, shorter. That's it, right? We're going to the left and up. So the cosine is negative, the sine is positive. This is called quadrant 2. I don't think you have to memorize what positive or negative in quadrant 2. You just look at it. This is quadrant 3. This is where everybody is negative. It's sort of the opposite world of the nice and cozy quadrant 1. In quadrant 3, everything is negative. So the two coordinates of this point is minus 1 over root 2, minus 1 over root 2. And therefore, that's the sine and cosine of this angle, which is, what number can we put to this angle?
225.
225. Exactly. You can say 180 plus 45, or 135 plus 90, or 45 plus 180. This is what it looks like to add 180 degrees. Exactly. And then this is going to be, oh, now the x coordinate is positive, the y coordinate is negative. That's it. So it's just, with 45, it's just the variations on the sign. And that is also told you by the unit circle. So you understand you don't have to memorize a great deal or nothing at all.